I have a quick question for you guys. You need to observe and answer. Is 15 more or less? Yeah, please do answer that. Is 15 more or less? Let me ask you next question. Is this bus moving? So time is, is time is moving forward. Is the bus moving? Or let me ask you this. Is this dot moving for you guys? Now, if you felt weird in any ways with this three question that I asked, let me rephrase it. Is 15 more or less than 14? Is 15? Let me rephrase all of this so that, okay. If I happen to ask you guys, is 15? So what I'm asking is 15 more or less than, I'm erasing this, 10? Right? Next, I want to ask you guys, is this bus moving? In the background, there's supposed to be the mountain and the stick and the green thingy that you're seeing over here. That's supposed to be a tree, and we have the time. And us watching the bus, what do you think now? Is the bus moving? Is this dot moving? Right? When you watch a movie, the camera is pinned to the car. Things around that, they keep, yes, they keep moving, is it not? Right? If I happen to take this, if say this is a scene, movie scene, and there are other vehicles on the road. Okay, so there are other vehicles on the road. Oh, I should have done that, my bad. There are other vehicles on the road, something like this. And if I happen to show it something like this, if this car is faster and say he or she is chasing this car and their speed is same, so the green car will look as if it's going back. It's slow, it looks like that because they overtake, right? So they overtake. So this green car keeps going back and back and back. If this is the center, things around that feels like as if they're moving back or forward, whatever that is. If this car is overtaking, all this car feels like they're stationary. Everyone is moving. You've seen all of that, right? In movies, in TV, basically. So what I'm trying to give you guys over here is, what I'm trying to introduce over here is a reference point. The word reference point. What is this? Reference is nothing but in comparison to something else, what is happening to the first quantity. For example, 15, if I have to compare, I need to have the first quantity. Or if this being the first quantity, I need to know with what are we comparing. 15 more or less than 10 makes more sense than me just asking, is 15 more or less? This is not answerable. What is answerable? Is 15 more or less than 100 or 110? Answer is yes, 15 is less than 110. And when it comes to bus, yeah, it's not a very good animation, but you can imagine that, of course, trees are stationary. But if you see a tree moving back and you see the wheel and all of that, you can imagine. Yes, with these trees as the reference, you will be able to tell that the bus is moving forward. So that is your reference point. So reference point is very much important for your concept over here. All the things that you learn in 2 dimension, any kind of motion, any kind of movement that you see. In physics, we just see movements. Everything moves in physics. Of course, there are scenarios wherein things does not move, but again, if something is not moving, that is also with reference to something. So reference point and frame is a very important concept. Motion is all about change in position of an object over time. This definition you guys already know. The word change, right? The word change needs a reference to continue the discussion. If I just show a dot, it doesn't make sense. If I just show a bus, it doesn't make sense. But if I show things around that they are moving, right? So either you can tell the tree is moving, which is not possible. Tree by itself will not move. So obviously the dot has to be moving to the right. So the tree looks like as if it's moving to the left. Okay. So point is you need to have some reference to talk about anything, any kind of change, any kind of comparison. Thus any motion needs a reference point or frame. Okay. So I have, the definition. Definition of frame of reference or reference frame is a frame of reference is simply that portion of the world around us which we use to measure the motion of moving bodies. Right? A reference frame is a coordinate system that provides a framework for describing the position and motion of an object, like origin, axis, scale, right? So we have seen all of this. We have seen it in quite a few places. Say this is your x-axis, this is your y-axis. Then if I have a dot, and if we happen to take this and now move it around, now we can tell that it moved from second quadrant to first quadrant, and then to fourth quadrant, and then to third quadrant, and then on to the origin, and on to the x-axis, negative x-axis, positive x-axis. So we have a reference to discuss. So all my language, you can hear me telling, I'm talking in terms of this, just 2 lines, that's it. Those are your coordinate. So this is your frame. But if I remove everything, if I remove everything, as in, let me do this actually for you guys. No, okay, let me remove everything on the screen. Now, if I just put a dot, okay, and if I do this, how can I describe this? There are ways, yeah. I can tell I kept the dot to the left extreme of your screen. Now my reference frame is what? Your screen. Top. If I can't use the word screen, how can I describe it to you? It moved top. I'm using the previous reference frame. As in, the point was over here. With respect to that, it moved top. That's what I'm telling. It's moving top. It's moving down. But if you guys close your eyes now, if I kept it somewhere, and if I tell it moved, then it moved. Okay, you won't be able to tell if it moved right or left. Are you getting it? So you always have some point of starting point, basically. Right? If someone tells you have improved. So improved means what? Previously, whatever you did the work, compared to that, you have improved. So there too we use a reference frame. So reference frame, reference point is used everywhere to discuss everything. In this world, it is used directly, indirectly in every conversation. Okay, so it's there in every subject, it's there everywhere. So it's not only a physics topic, it's pretty much there everywhere. So now I kept using a reference point and reference frame. What is this reference point? As the name tells, it's a dot, right? It's just a dot. It's a fixed location. While reference frame is a full-fledged coordinate system. If you have x-axis, if you have y-axis, if you have a bunch of lines like over here, I can do this. I have a bunch of lines to discuss, and I can draw, I think, I erased it off. If I happen to draw a line over here and this line, now I have a bunch of lines, quadrants, and so on and so forth. Then I can use ticks, that is divide the set of lines into equally spaced values and so on and so forth. So that is your reference frame. So components of a reference point is just a single point, right? Just a point. Components of reference frame is origin, axis, scale, and all of that, right? You need to talk. We can talk about origin over here. Then we have ticks also. You have marking. Then we have axis, scale also. We can use the concept of scale over here. That this particular length measures 1 kilometer. If you look at any map, we can see them to be 10 kilometers, 100 kilometers, 500 kilometers, so on and so forth. Right? Even in Google Map, if you guys use that, any kind of map, right? India Map app also, if you use by Indian, I think owned by some Indian company or in government of India, I forgot. So there too, the concept of scale comes in. If you use any map app-based app, there too you get to see the scale concept. The purpose of any point is determine the position or motion related to itself. While reference frame provides a framework for describing position and motion of the object. Right? So that's how, everything has its own use. Example, starting line in a race. Example, grid map of a city or a country or a state or anything. Next, one more word that you need to know is initial frame of reference. Sorry, not initial, inertial. What is inertia? Have you heard of the word inertia? Inert. You should have heard this word by now. Inert. I'll give you guys a clue. It's related to, you can hear it in chemistry actually. I was able to write chemistry. I'm writing compound though. Atoms. Inert, what? Inert gas. You guys remember what is the property of inert gas? Yes, that it does not react easily. So when it comes to inertial frame of reference, let's see what is this about. An inertial frame of reference is a class in classical physics, and special relativity is a frame of reference in which an object with zero net force acting upon it. Okay, sorry, just a second, it's not complete. Okay, now it's complete. So acting upon it moves at a constant velocity, which can be zero. Okay, let me put it this way. So if I have an dot right over here, so this is not moving. There's no force acting on it. It's not moving. If I have a force acting on it, then it moves. It can move. If there is no force, it stays. Remember, motion is respect to the surrounding. Okay, so example, let me go to this example, bus example. If I happen to switch off the gadi, say near this tree, some kid had to poop or pee, chotu kid. So time will keep going. This is also, forget about the time over here. This is what happens. With respect to this tree, this gadi is stationary. Okay, so this is this background mountain and the trees are your inertial frame of reference. That is the framework. If your object is not moving, the frame remains the same. Such a frame is your inertial frame of reference. You can ask, where does background move? Say you have a train that is standing, So you describe to your friend that you're standing at the front of the train, like over here. But what if the train itself moves off? Then are you still standing in front of it? Say it moves off, it goes off. Are you still standing in front of it? No, right? So this being an initial frame of reference, it can't be an initial frame of reference. The train, if you describe your position with respect to the train, you're waiting in a metro or you're waiting in a railway station. Say you are near to the engine or the first bogie or the first 1A, how do I put it across? One tire AC berth and all of that. I'm not getting the word, sorry. So you got the funda na? So if you use that as the frame, yeah, it is there for 5-10 minutes. After that, what happens? It moves. That is not a initial frame of reference. Initial frame of reference, it has to be inert. That is, it should not change. So if you have an object which is not experiencing any force, it should not move. Right? Constant velocity can also include zero velocity. That's also constant. Something being zero, constant is constant. It should not change basically. If something is 0 meter per second, it has to be 0 meter per second. And the surrounding, say this is a house. It looks more like a house than a bogey. Actually, if this is a house, then it's not moving. If not for a landslide or something like that, it doesn't move. So if you're standing over there, you will continue to stand over there, as in next to the house or this meter away from the house. So this is the initial frame of reference. But instead of this being a house, this was a vehicle. So will this be our initial frame of reference? Answer is no, because the vehicle can move. It moves. Okay, guys. So what we are trying to understand is that we can't compare, we can't talk about any kind of motion or any kind of change unless we have a reference point. And we saw example 15 is more or less cannot be answered because 15 needs a reference point to discuss the more and less aspect. And the bus will not move, or it doesn't look to move. Oh, sorry, not that. This. We don't have anything to refer to. Right over here, everything looks, no, there's no background. Even out of space, if this vehicle was going straight forward, if the background space is empty, you'll not know if it's moving or stationary. So we need a reference point or a frame for us to discuss any kind of change. So motion is all about change. So to discuss change, we need a reference point to continue any kind of discussion. Thus, any motion needs a reference point or frame. So we have the definition, frame of reference or reference frame. So it is that part of the world which gives us a reference to discuss motion. So reference points are just points. Reference frame are your coordinate system. You have origin, axis, scale, and all of that concept comes into picture. So initial frame of reference is that frame of reference or that part of the world which is stationary. How do we get to know that the world is stationary when we are describing the motion over there? If you have an object moving at a constant velocity that includes the rest, the object will continue to be at rest. Okay, if you tell the person is 10 meter away from the house, he'll continue to be so. But if this is a vehicle, what happens? If the vehicle moves, he won't continue to be at 10 meter away, right? In this example itself, in this rough sketched example itself, if this was a vehicle, floating vehicle, gliding vehicle, it is moving. It's out of the screen. So it's not 10 meters anymore. Right, guys? So that's how you can think of it. It's it's kind of simple. I'm sure you understood. Okay, if you want to make a note of something, please, you can pause and have a look.